Hi, good morning. In today's session, we're going to focus one of the optimization techniques. It's called search optimization service in Snowflake. It's one of the service provided by Snowflake. The name is search optimization service. Now we'll discuss what is meant by search optimization service provided by Snowflake. Mostly we'll use this service for optimization. Now, optimization means you have to get some good performance if you are querying a large volume of data. You have large volume of data. From the large volume of data, I want to get a smaller subset of results. Satish, I have terabytes of data. From the terabytes of data, I want to filter few of the categorical variables. Okay, categorical variables means, for example, shirt size, small, medium, XL, double XL, is that right? These are called the categorical variables. Or some columns having like medium, large, X large, these all called the categorical variables. If you want to get some subset of data from large volume of data, definitely you will apply some filters. In SQL query, what you will do? You will apply some filters. What the filter will do? It will go and scan the record by record, and then it will give the results. It will give the results. But in Snowflake, what will happen, right? Every data is split in terms of micro partitions. Micro partitions. It will go and scan the each partition and then going to fetch the filter results. For example, I am putting shirt size equal to small XL. Sorry, you can put XL. It will go and search all the micro partitions and then it will get the results. Definitely, it's going to take more time. If I have 10,000 partitions, it's going to scan all those 10,000 partitions one by one. It will take more time to get the results. That's the reason Snowflake introduced one feature called service call. Service call search optimization service. You can go and search what are the filtered results. What are the results you are trying to filter from a large volume of data? You can do it through one of service called search optimization service. It will give good performance. It will give good performance. It's one of service. Okay, it will give good performance. If you try to filter some data from the large volume of data, it will give good results. Now, you already guys know what I am doing the search optimization. I'm going to filter some records from a large volume of data. That's what I'm going to do. But I'm going to use one service. Okay. Before applying some filters, you know, right? Predicates. Like you're applying some where condition, you're going to filter some values. Before applying some filters, I want to apply that column into the search optimization service. Which column am I going to filter, right? That column I want to add into this search optimization service. Then it will give optimum performance. Okay, now the example one, example two. I'm going to take two tables. One table column I use search optimization. Another table column I didn't use search optimization service. Now the table A will give good results. Okay, now I'll say how it's giving good results. We'll see one by one. Before going to search optimization in detail, before dwelling into the topic, I will say how the search optimization works in Snowflake. Now, if you see here, right, you will write some SQL queries on a file. The SQL queries will apply all kind of filters like where condition, you will use and condition, or condition, multiple and multiple or, all kind of queries you will write in the SQL file. Now, if the search optimization service is enabled for the particular table, it's going to create additional data set called search access path. Satish, I'm saying again to you, you're writing some SQL queries and then you are enabling the search optimization service on the tables column. If you are applying search optimization service on the table column, what will happen, right? It's going to create additional data set called search access path. Sindhamul and Sujita Priya, whenever you are trying to enable search optimization service on a table, it's going to create one additional data set called
search access path.
Search access path. What the search access path will do, right? Though you already know, in the storage layer, all the data will be stored in micro partitions. Some data will be here, some data will be here, some data will be here. All are micro partitions. Whenever you apply search optimization service in a particular column, it will going to create additional data set called search access path. The search access path is going to monitor all the micro partitions where the table values are stored. Now, I'm going to give one example, guys. I'm going to have one column called fruits column. In that fruits, I have some values called apple, orange, grapes, banana. Grapes and kiwi. Okay. And then banana. Sindhamul like this fruit banana. Banana. Now, all these variables are called. What we can say? What we can say? Few minutes back I said all these things to you. What we can say the values are? What values it is? Now,
Fruits, sir.
I know fruits, man. What kind of value it is?
Variables.
Categorical variables. Apple is one category. Orange is another category. Grape is another category. Kiwi is another category. Banana is another category. This is called the. These are called the
categorical variables.
Category variables, and then price. Prices. I'm just keeping the price of 1 kg, like 240 rupees. Orange price is around like again 220 rupees. Grapes 80 rupees per kg, 90 rupees per kg. Kiwi is going to be somewhat 300. Banana is going to be 70. And then apple is going to be again it's coming like it's a small apple. Okay, just we'll make like 210. Now, what kind of variable is 240, 200? It's a continuous variables. It's continuous. Value is continuous, right? Just keep on changing. What we can say it is
continuous variable.
Continuous variables. What are the variables it is? Fruits column.
Categorical variables.
Category variables. They are categories. Apple is a category, orange is another category, grape is another category. These are called categorical variables. In machine learning terms, we won't say the columns, we'll say the futures. We won't say the column. What do you say?
Features.
Features.
Price is another feature. All are called the independent variables. Okay, like fruit is an independent variable. Okay, price is also independent variable. Now we will say all the features. Sometimes I will say futures, don't get confused, guys. I'm saying the columns, names. Okay, if I say somewhere futures, you have to think like this guy is talking about the column names. Now, good. Now, I'm taking fruit column. Whenever the table name I'm going to keep, like, okay, fruit market. The table name is going to be keep fruit market. In the fruit market, the fruit column, I'm going to apply the search optimization service in one of the column name called fruit column. What will happen, right? The search, it will going to create additional layer called search access path. The search access path will go and search where the apple micro partition is, where the orange micro partition is, where the grape micro partition is, where the banana micro partition is. It's going to keep tracking of all the micro partition where the value contains. Now, which one is having the updated information? Which one is having the updated information?
Sir, search access path.
Search access path will all have the information. For example, later I'm changing apple is. I'm changing apple is. Give some fruit name, guys. Jackfruit. I'm changing the apple as jackfruit. Now what happens, right? Whenever some update happened in the micro partitions, again it will keep track of all the informations. The search export will have all those information in this jackfruit content, which micro partition, kiwi content, which micro partition, keep all the information. If it is get updated also, it will be updated. The search export going to improve your query performance by reducing the amount of partition scan. Now I'm going to say, if the search export knows this partition, why we want to scan the unwanted partitions? For example, in this partition, no fruits are there. Whatever I want to filter, right? In this micro partition, some other fruits are there. Okay, I can say berry fruit is there. Okay, berry is there. Berries is there. I want to filter only jack, orange, grapes, kiwi, banana. Now the search export, what will do, right? It will skip those partitions. Whichever partition having jack, right? Berries, it will going to skip those partition. Not jack, it is going to skip the berries partition. Like the remaining fruits partition, it is going to skip. Whatever value is going to filter, right? That value is only it's going to scan. So not understood, right? The search export will have the information about all the micro partitions, what are the value contains, and then, for example, if you are using some filter, right? I'm putting filter fruit equal to orange. Now what will happen? Already the search export knows which partition orange contains. It go and scan only the orange partition. It's going to skip all the partitions. If it skip all the partitions, whether my query performance will be improved or not.
Improved, sir.
Improved, because this search explorer knows all the information, right? Like it knows where you want to go and search the partition, micro partitions. Okay, it won't scan the remaining partitions. That's why we can improve the query performance. That's why the search export playing a major role. If you want to create search export, definitely you have to enable the search optimization service in one of the column. Automatically, this additional data set will get created. It will keep track of all the micro partitions. If it get changes, it will be get updated. Okay. Now, whenever you're trying to filter, right, what happens? It will reduce the amount of partition scan during the table scan instead of searching all the partitions from the table. Now, good. Now, straight away we can go for. I want to say about when we have to use a search access path. When a search optimization enabled on a table, the process of populating data into search export for first time might take significant time depending on the size of data. What they are saying is, during first time, right, the search export will go and search where the micro partitions, where is the micro partition, in each micro partition, what's the values, it has to go and check. Definitely, it's going to take some time the first time. Okay. Second time of querying, right, it will give the results very faster. That's what the thing here is. And then when the table data is modified for a particular column, you applied search order service, what happens, right? It will update the information in the search export as well. Like if apple got changed to berry, now the information will be changed in the search export as well. And then the additional cost will be involved because we are creating this search optimization services that are going to create additional data part. Definitely, the cost also will be involved for storage as well as compute resources for maintaining and searching the access path. Now, good. You might think, what are the benefits of search optimization services? Now, if you are using some predicates, right? Predicates or some equalities, if you are searching column name equal to some constant value, column name in, I'm going to check whether some values there are not. For these cases, we can use the search optimization service. Sujita Priya, where you will use the search optimization services while filtering the constants, as well as if you are using in condition, right? The column name
Yes.
in, and then if you are searching some constant value like apples, oranges, grapes, is a constant value, right? Searching these values,
Okay.
definitely you have to go for the search optimization services. And then next thing is, if you are using substrings and regular expressions to filter some values, like using like operator, regular expression like, regex expressions, like, if you are want to use on the substrings, mostly we'll use these things in the substrings only, like or like, regular expression like. For this, you can go for, you can go for
Search optimization services.
search optimization service. Satish, when you have to go for search optimization services, you have to go for equality. Equality means checking the constant value, and then in predicate. Predicate means column value in, you're checking some values, whether the apple is there or not, orange is there or not in the particular column. And then if you want to search in the substrings, you can use like or like, regular expression like also you can use it.
Okay.
And then variant columns. You've seen, right, in Snowflake, we have some variant columns. You can have JSON key and value pairs. Columns also, you can use the search optimized services. And then fourth one is geospatial functions. Geospatial in the sense, latitude, longitude, these kind of values are stored in the tables column. Then you can use
Search optimization.
service. It will give the good performance while querying, while filtering, right? It will give good performance, I can say. And then mostly used in geospatial functions with geographical objects. Geography means point coordinates. Point coordinates, you know, right? Easting, northing, some 102.00 will come. Northing, easting, longitude. Okay, all kind of map coordinates. Okay, if you're working with the data, then you can go with the search optimization service. And then last one is congestions of the support predicates. Like you're using some AND condition or OR condition, in where you'll use multiple AND conditions, multiple OR conditions. For this, you can go for which services?
Search optimization.
Search optimization.
Service you can go for. Now, you might be thinking, how to identify tables and columns that benefit from search optimization services? I have 25 tables. Which table I want to apply the search optimization service? What are the benefits from this search optimization service? I want to know. Okay. If I know the which table I want to apply, then only I can go and apply the search optimization services. If your table data volume is having few hundreds of GB, Chandamal, if your table contains few hundreds of GB, then what you can go for? You can apply the
Search optimization.
Search optimization services. And then in the table, you have one column. Okay, in the column, you have 100 to 200K, thousands, distinct values. Then you have to go for
Search optimization.
Search optimization services. Because the column I'm going to use for filtering. Okay, in the column, it contains at least 100K to 200K distinct values should be there. Then you can go for search optimization. If it is less than 100K, right, no need to go for search optimization. Normally, you can use where condition and then you can use it. Okay, no additional data path will be created for you. Now, normally you can use high-level filters and then can filter it. Only if it is in this ranges, then you can go for the search optimization services. And then, yeah, the query returns only a few rows with high selective filters. Okay, now you are applying some high-level filters. Filter in the sense you're applying some where conditions. Okay, it's giving you only few rows for you. Okay, few rows means it will run in the back end, will give only a few rows. Okay, it will take more time. Okay, at the time you can go for the search optimization services. Search optimization service knows where the column value resides in each micro partitions. So the result is very faster. So you can go for the search optimization services. And then if your query taking more than few seconds or longer, what you have to do for? If your query taking more than seconds, more than hours, you have to go for search optimization services.
Search optimization.
And then now the table, what you have, right? The table, everything will be micro partitions. And then the table is not clustered. Okay, it's not clustered. Okay, it's not clustered based on cluster key columns. Then I can go for the search optimization techniques. Good. Now, next step is very simple. How to enable the search optimization service for your table in Snowflake. Now, I'm going to say a few commands, guys. Okay, just look at here. First, create one table. Radesh, first you have to create one table. Table, any table. Okay, it can stand a table or any table you can create it. And then you have to alter the table, put the table name, and then you have to use the add search optimization on. You have to use equality. Equality means I'm going to choose the constant value where column name equal to value you're going to put where column fruit equal to apple, fruit equal to orange. That is called equality. Equality means you're going to compare. Okay, you have to use this statement add search optimization on. You have to use a function equality, and then you have to mention the column name. What column name I mentioned here? What column name?
C1,
C1 column and C2 column. In these two columns, I can apply the filter. I can apply filter where I can use. See here, guys, that's what I said, right? That's what I said. You can apply the filters where condition in condition you can use it, and then you can use like or like regular expression like you can use geography function you can use, and then you can use multiple and multiple or these kind of filters you can apply it. That's called equivalent conditions. And then equivalent conditions you can apply only in or equal to. Okay, you can't able to apply regular expression or like you can't use it. Now what I'm going to do is I'm going to use same table T1, alter table T1, add search optimization on substring. Now, what are the string columns you have, right? You can use regular expression like, all kind of regular expressions you can use on the particular column. Which column I'm applying for?
C3, sir.
C3 column. Okay, now if you creating search optimization, right, what will happen? Search access path additional data layer is created. It's going to keep all the information of micro partition where the column value resides. And then if the value gets changed, the search access path will get updated. I shown the diagram, right? Search access path will keep track of all the informations. Now, good. You guys know how to add the search optimization. First create a table and then add the table, add the search optimization. If you want to put equal to, like filters, go for equality. If you want to compare some strings using regex or like regular function like, you can go for substring. Okay, now what I'm going to do is, if I want to apply multiple search methods on a table on the on class, what I have to do is add the table T1, add search optimization on equality and a comma, you can give substring. Now in the same column, what I can do? I can do the equality operation as well. I can do the substring in the sense like I'm using some regular expression likes or regex. I can use it and then I can filter the values. String values I can able filter. String values I can able filter this. Like multiple search methods can be applied on a single alter statement. This equality only for C1, C2. Substring only for C3. Okay, now good. Now, I want to show guys one thing. Yeah. I want to identify search optimization is configured on a table or not. Configured on a table or not. Just give what I have to give is put show tables. If you give show tables, right, it is going to give 3 columns for you. Okay, I'll say that what are 3 columns. I'll show the column, guys. If you click show tables, right, like I am product table name. Table name is
line item, sir.
line item. Okay, I'm using like operation, which is starting with line item, right? It's going to give 3 additional columns. Okay, the first one is name. It's going to be the table name for you. And then the first column is search optimization. That's what they're saying here is, if you look at here, the value of the first field, search optimization will be on or off. If you are enabled, right, it will give on. If the search optimization disabled, it will give
Off, sir.
off. The same thing you can follow in this table. Now we have 2 tables. In the line item SOS, search optimization is
On, sir.
on. Line item non-SOS is
Off, sir.
off, because in this table,
Okay.
right, the search optimization is not enabled. Now the second column is search optimization progress. What happened, right? It will give the progress bar, like how much of search optimization progress will happen, because it's want to go and scan all the micro partitions where the column value resides. If it is 100%, 100% optimization progress has happened. You seeing, right? 100 means 100%. The optimization means it did the entire search, and then this search access path knows where the column value resides. It will come 100%. Now, in the initially what will happen, right? It will go on scan, right? At the time you can see the percentage, 20%, 30%, 40%. It will keep on improving and finally come to 100%. Now, what percentage now?
100%.
It scanned all.
100%.
It scanned all the micro partitions now. It scanned all the micro partitions. It's having all the paths where the data resides, where the column value resides. Everything will have. That's what I want to show is the search optim progress field. It's a progress field indicates the status of creation of search access path. Okay. Now, what I want to say is 100% it having the information. Now the search access path is got created. When it having all the information, then only search access data path will be created. Okay. Now, third one is search optimization bytes. Because I already said to you, the search optimization, it's going to have the storage as well. This much of data it's stored, you can see in terms of bytes as shown, indicates the amount of storage consumed by the search access path built for the table. Okay. Now they are saying in terms of storages, this much bytes of storage were taken by the search optimization, because it has to know the path, right, where it has to take the data. That's why it's taking this much of bytes. Good. Now, what I'm going to do is I'm going to show a demo to you guys. Okay. First thing is the same example. You can try some other example as well. First I'm going to demo DV. And then I'm taking data from the Snowflake sample data. Schema is TPCH SF 1000. And then line item is the table name. Now, from this table, I'm copying the data into
line item.sos.
line item.sos, because I'm using CTAS. Srita Priya is using CTAS. Do you know what is CTAS? Create table.
Create table as, sir.
Create table as. That's called CTAS. Now using create table as CTAS, I copy the data into this table. Now this table will be a permanent table for us. And same thing, what I'm doing is I'm creating, I'm cloning this table. Already I have one table, right? Line item SOS. I'm just using the clone operation. Already I discussed the clone operation with you guys. Clone operation, right? From this
Yes,
line item SOS, I am copying data into line item
in non-SOS, sir.
non-SOS. Okay, after copying data table, just I'm cloning the data. Okay, cloning the table, not cloning the data, cloning this table into this table. Cloning will take less time. That's why I'm going for cloning. Okay, if you're copying, right, it will take more time to copy the data. That's why directly I'm using the clone command. We can able to clone this entire table and then rename this table name as line item non-SOS. Good. The same command I already did. You guys can see, because why I did this, because it will take more time to copy the data. Because this contains petabytes of data. This table contains petabytes of data. So that's the reason while starting session itself, I created a database. I copied the data to the line item SOS and finally I cloned. Now, if you click on the demo DB, you can see in the public schema, you can see the tables. In the tables, we can see the two tables. One is SOS, another one is
Non-SOS.
non-SOS. Okay, I think up to this point you are clear, right? We are creating the one table and then just cloning. We have two tables right now. One is non-SOS, another SOS. Now I'm going to do a simple thing, guys. I'm going to enable the search optimization table. Already said, right? In add table, you have to use this command, add search optimization. Search optimization in the on class, we have to use a column name on the equality function. If you apply equality, right, what happens in the particular column, you can apply the filters, then it will give the results very faster. Within a milliseconds, it will give the results very faster. Milliseconds or seconds it won't take more than more than like 2 minutes or 3 minutes. It will give the results very faster because we are applying the search order services. It's going to create the search access path. The search access path will have all the informations, right? Now just copy it and put it here. Now just I'm doing is enabling it. Now you can see it's got enabled. The statement it is successfully. Now next step, what I want to do is I want to check whether the optimization progress, okay, whether the search data path is created or not. For this, what command you have to use?
Show command, sir.
Show tables command you can use. Who said show command? Show tables, and then you have to use the like
show
operator,
table.
And then
okay.
Which table name required, you can put the line starting from line item, it will be displayed. Just copy as it is and then place it here. Now you can see when it's got created, what's the name and database name and schema name, kind of table, and I didn't do any clustering here, or how many rows we have, and then how many bytes, and then you can see like who is the owner, and then retention time is 1, clustering is off, tracking is off. Now you can see there's a one additional column. You can see what is the column name. What is the column name? You can see here.
Search optimization.
One table is off, another table is on. Yeah, one table is off, another table is on, right? And then you can see the search progress. Now, what happening, right? It's not creating search data path. Do you know why? It will take some time. I said, right?
Yes,
it will take some time to get 100% because it's going and scanning all the micro partitions, and then it has to collect the information, and then it has to keep those information. That's why it's showing like 0. And then you can't see the bytes as well because it still is doing some scanning process. And then once it got all the information, it will collect those, how much of bytes for storing those informations. These are the information you can see. Okay. And then if it is hybrid table, I took hybrid table, right? Hybrid table, iceberg table, dynamic table. all kind of informations you can able to see. Suita Priya, whenever talking interviewer, you have to talk about these tables. What general tables, what hybrid tables, iceberg tables. Okay, these are the information you can see. Okay, now everything is good. Now I'll run one more time. Let's see the progress. Guys, it will take some time, guys. It's one of services. Just if you scroll down, I think it's still showing 0. It will take some time. That's what I mentioned in theory as well. Good. Now, the next thing is, what I'm going to do is, I'm going to filter the values because I applied the search optimization on a particular column called L order key, the column name. In the L order key, what I'm going to filter? What value are going to filter?
Sir, 41 lakh.
4118.
411,832,961. Some huge number are going to filter it, right? Just copy this one and filter it. See, guys, I think now it won't give that much good results because it has to create a search data path. Now, what I'm going to do is just I'm going to filter the record and seeing the time, how much time it took. Let's see the time. It's taking, it won't take this much time. If the search data paths get created, right? It won't take this much time, guys. That is how much seconds it took?
Sir, 9.1 seconds.
9.1 seconds took, but still, I think it's doing a scanning only.
10 seconds.
What happened? Yeah. I think now you see. Sendamal? Now you can see what happened. Search or progress. 100%. Now the search data path got created. Additional data layer got created. Now it's holding like this much of bytes. 39 GB. Okay, 39 GB. It's got created. Now you can see the results very faster. Bro, so sorry, like I want to say like few things. If you are running the same query again, right? Those Snowflake will have the default caching, right? It will give the results very faster. See how much time it took now.
96
90 milliseconds. Just will search for some other value. Let's see how much time it's taking. Don't run the same query again because caching will be enabled by a default in Snowflake. That's why the power is in the Snowflake. Whenever you're using same query again, it's catching, it will store in the cache and it gives results very faster. Previously it took 9 seconds, now 90 milliseconds. Now see. Yeah, now 9.2 seconds, I guess. Let's see. Yeah, it's sound because it show. I want to show in the UI, right? It took taking 7.8 seconds. It taking 7.8 seconds. Now we want to see the same thing. Which table we have enabled the
search optimization.
Yeah. Now we have seen that we are querying the line item non-SOS. Okay. SOS means non-SOS means non-search optimized service. In this table, I have not applied the search optimized services. It's giving how much time? How much time?
7.8 seconds.
7.8 seconds giving. Just go to the query ID. You can see the query profile. You can see, right? First initial table scan also happened, and then some filtering is happening. Final result is coming to you. Okay. Now, if you see how many partitions were scanned, totally how many partitions we have?
Sir, 9,300.
53 partitions we have. How much are scanned? Sendamid and Sujapriya?
9352, sir.
Totally it's got scanned, right? Almost like 99% got scanned. Okay. And then you can see the total byte scan was 24.66 GB where it was scanned, and finally you get the results. Now, what I'm going to do is I'm going to show this table to you. Show tables like the non-SOS means non-search optimization. I have not enabled the search auto service in the tables. In line item SOS, right? Search optimization enabled. You can see it will be on here. It will be on, and then it will give 100%. Now, search data path also enabled. Okay, good. The same query I'm going to apply. Just I'm going to change the table around. Now you're going to see the time. Initially, it was took how much times? 7.3 seconds. Just I want to change the table name. Line item. Line item.
SOS, sir.
Yes,
SOS, search optimization services. SOS means search optimization services. Let's see the time. Though are in first time, right? Let's see. How much time it took?
1.9 seconds.
1.9 previously it took. The non-SS took 7.3. 7.3, 9.3 seconds it took, but it's taking nearly 1.9 seconds. This is how you can improve the query performance. It's one of the optimization technique. You can improve the query performance. Now, I have shown the difference, right? But here, I want to show the query profile as well. Click on the query profile. You want to see how much of partitions were scanned out of the total partitions. You can see the below one. Just once again. Out of 9353 partitions, how many partitions were scanned?
7%.
Only 7 partitions were scanned, the remaining all are pruned. Because the search data path will have where the column value resides, only the particular partition will be scanned. The remaining partition will be pruned. This is how you can improve the query performance. And then you can see total byte scanned is 249 point some MB. Previously it was, you can see the difference. It was
24.66
GB.
sir.
Because it's scanning only less partitions. That's why it's scanning only less MB. That's why it results very faster. Now I have shown the difference, guys. Now, as per the pictorial view, I want to show the comparison of stats for their queries. What I have there run, right? There is a huge improvement in the query runtime. Previously, for non-SQS, right? Non-SQS means it taking around the time of, they're saying like it's take around 63 seconds it took. Non-SOS. Search auto service took 63 seconds. But SOS took how much seconds? Sorry, 2.3 seconds. SOS took 2.3 seconds. This is how you can able to see the query performance. And then if you are using non-SOS, right, 99% of partitions are scanned with the query. But if you use SOS, only 7 partitions were scanned out of 9317 partition. This is going to the massive improvement in the performance as well as execution time. The third one is you want to see the number of bytes were scanned. Non-SOS, it took how much of GB? 24.47 GB. But if using SOS, applied on the table column, it took only 91 MB with search optimization service is enabled. This is how you can see the query performance. Now we're going to see how to identify which columns are configured for search optimize service in table. You want to identify columns, right? Because I don't know which column I applied for. Someone applied for some columns. I don't know which column they applied for. Because Sendamal did the development, he applied search optimize service in one of the particular columns. I want to know which column it belongs to. For that, what you have to use? Describe search optimization. And then you have to give the on class, you have to give the database name, schema name, and then table name you have to provide it. And then you can see all the columns. In which column the search optimize service was enabled. Just go to your Snow site and then you hit on enter. And then paste your SQL command. Just hit enter. Now you can see in which column the SQS is enabled. Now you can see that the method is equality. Target is
L_order key, sir.
because I applied, you can see in my cursor, L order key only I applied the search optimization service. The target data type is going to number. Okay, and then it's active now. If it's inactive, right, it will be false. So it's active. This is a way you can able to search where in which column they applied the search optimization service. Now we'll come to the pointer number 9. How to disable the search optimization? Very simple. You have to use only drop search optimization. That's it. What you have to use?
Drop search optimization.
Search optimization. If you want to disable the search optimization service in the Snowflake. But you have to use the order statement, guys. You have to use the order statement and then you have to apply it. These are different ways. Okay. If you want to a particular column, you can use the drop search optimization services. And then if you want to drop the entire columns, for example, 5 columns, you applied the search optimization. If you want to drop everything, just you can put the drop. Okay. Now what I'm going to do is I'm going to Snow site. First, I'll create one more. First, what I want to do is just I will query this table and see what are the columns we have. Select star from limit 20. Now you can see, I going to just I'll see is there any category variables are there or not. Okay. Now I will take this discount L part key. Okay. L_part key I will do. Just have same statement, guys. Now I'm going to change the column name as
L part key, sir.
Sundamal. What I'm applying here?
For L part key, sir.
L part key. L is caps a small letter. I'm not sure. L is small or caps. Let's see.
Capital, sir.
Capital L only it is. Okay, good. Now we'll make the okay. It's a case sensitive, right? No need to put uppercase, lowercase. It should be a part key. Part key. Good. Now what I want to do is I want to apply one more search optimization services in one of the another column, L part key. Now it's successfully executed. And then if you scroll down a little bit, just come here. And then you can describe, okay. Now we will display the 2 columns it was applied. Okay, now what I want to do is, just I want to disable the L part key. For disabling the L part key, what might I have to apply?
Drop, sir.
Alter. I need a full statement.
Alter drop.
This is the way I did, right? Alter. Guys,
Table.
that's why I keep on saying to you, whenever you are doing, right, just think twice or thrice, okay? We have to put the table name and then you have to drop. Just to Sujata is saying alter drop. What's the, I don't know what she's saying actually. Alter drop. We have to visit a table name and then provide a table name as well. Finally, you have to give that drop search optimization. Now, just what I want to do is, just copy this one and place it here. Though I applied the equality, right? Remove substring, apply the equality. Apply the equality. That's it. Table name is, what's the table name?
Sir, line item SOS. Sir.
Who will say the database name, guys?
Sir, demo DB
Schema
dot
name and
com-
then
schema name
table
dot
name.
table name. Sir.
Provide the, yeah, that's it. Now just say the column name. You have to say the column name, right? Give the column name. Which column name
L
I have to
part,
remove? L part key.
L part key. Sir.
Just copy and then give it here. That's it. This is the way you can able to drop it. Now I have successfully disabled it. Again, you can go for describe and see it. Okay, good. Good. Now, next thing is the last one we're going to see. We're going to see the billing cost of search operating service in Snowflake. I already said, right? It's going to incur the additional cost for storage as well as computations. For storing also, they're going to charge the cost because the search data path will going to store all the information in the data layer itself. So it will charge for storage as well as compute resources. How much of partition it has scanned, right? It has needs some CPU, it has needs some memory, right? Then only it can able to scan. And then depends on multiple factors, how much columns they're using. If you are using multiple columns, right, for search audio services, then the cost will be more. And then if the table column is having more number of distinct values means it's not carrier variable. All values are continuous variables. If you are all continuous variables, right, not having any duplicates, all are continuous variables, right, then the cost will be more. So in the column value have more number of distinct values. There's no duplicates. Okay, there's no carrier variables. At the time, the cost will be more. And then if you apply the search operating service in multiple columns, right, more number of columns, the cost will be more. And then compute resources, when it utilized, right, whenever you're creating search optimization, the search access path layer will get created. What will happen, right? It will go and search all the micropartitions. For that, it needs some computing resources. And then maintaining the search auto service when data is modified. If some data is getting modified in a table column, what happens? Again, the search path has to be get updated. For that, it needs some compute resources. For that also, you have to pay the cost. In order to identify the search auto cost, we have one system function, Snowflake system function. It's not your function. It's a Snowflake system function, system dollar of what function I have to use? Estimate
Search
search or a
optimization
cost function. This will give the cost, how much a cost was incurred for the compute resources as well as storage part. Because I already said, right, to build the search path, we need a compute resources as well as whenever you apply for multiple columns, it's going to scan all the micropartitions, all the data will be stored in the search export layer itself. For that, storage cost also will be involved. Now, what I'm going to do is very simple. Just I'm going to copy as it is. In that, I have to provide my database name, schema name, and then table name. First, I apply for line item non-SOS, and then I want to see the cost. No cost will be involved here. And then I want to change the table name, and then I want to show the cost for this. Just copy as it is, and then just hit enter. But this function they'll ask in the interview. Some system function, what I teach so far, right? Every service to some system function, they will ask in the interview which system function you used to find the estimated cost. At the time, you have to answer these things. Now hit enter. It will take some time, guys, to incur the cost. What are the costs incurred, right? It has to get those cost informations. I think now we can get the results. You can see it's like a variant column. Variant, right? Now you can look like a JSON. Just once again. Yeah. Now you can see liner non-versus search or enabled, it's false. Why is giving false? Search opti enabled is false.
Sir, it is not enabled.
It is not enabled for this table, right? And then they are the cost, questions, name, build cost. Okay, these are normal Snowflake costs. Okay, like value 2.33002 and units credits. And then you can see the computation methods for storage as well as computation. You can see the charges. Just if you scroll a little bit, if you scroll down a little bit, you can see like yeah, 0.14387. See, guys, they are saying the normal cost. Okay, per TB, the charging is 0.143 value, credits value. Okay, for computation, maintenance cost, computation is not available because this table is not enabled, right? Table is too young, requires 7 days of history. Satish, what is saying to you? Saying to us, insufficient data to compute estimate for maintenance cost. Table is too young because today only I credit. It requires at least
7 days. Sir.
7 days
of it, sir.
to see the table history. And then if you see, like, these are the default values they are giving to us. Okay, like these are values, credits, build the cost, because we have to build the search data layer, right? For this, the build cost will be 2.33 credits for building that search data layer, right? Search data layer, I show the diagram to you. Search export layer for building cost also involved. You can see 2.33 credits there. Now, just what I want to do is I want to change the table name. Just change the table name as Sujita. We have to change the table name as SOS and then see the estimate. It gives the variant type. Because its table is too young, right? Today only credits. That's why not giving much information. After 7 days, you can see the 7 days histories. Whenever get some time, just go on probe and get some informations. While probing, you will get more informations. Now you can see it took 28 seconds, and this is a variant type. You can see the build cost is 2.30148 credits, and then storage cost is going to be per TB 0.143837, and then compression methods, because it's not giving much information, guys. I think the table is too young. If it is after 7 days, right, you can get more information. Okay, as of now, they are giving the default credits value. Okay, for building that search access path, 2.301814 credits. And then for storage cost, they are charging us 0.14387 per TB, terabytes. Okay, now straight away we'll come to the last layer. Yeah, this is what is showing us JSON to us. That's it. Now, in the interview also, you can say all these things like I used the search optimization services to improve the query performance. And then you can say like we have to enable using alter statement. And then I can apply for multiple columns. Mostly I use in the dimension tables because client will ask us some ad hoc reports. So that's the reason we have added those search optimization service in one of the column. Whenever you are adding the particular column, search data access path will get created. It will create some. It will have some compute resources as well as storage cost is also involved in that search data path. Sorry, search access path. I hope it's clear. I'm going to close session right now.